Hi students, in this video we are going to discuss the question number 1 and 2 from first chapter of physics, Numericals. So let's start to discuss. So first question, what is the force between two small charged spheres having charges of 2 into 10 to the power minus 7 coulombs and 3 into 10 to the power minus 7 coulombs placed 30 centimeter apart in air? First of all, let's try to figure out this question. So let us assume the two small charged spheres as Q1 and Q2 and the distance between them as d. So Q1 will be 2 into 10 to the power minus 7 coulomb. Q2 will be 3 into 10 to the power minus 7 coulomb. So we are assuming that as Q1 and Q2. And the distance they have given in the question as 30 centimeter. So D is equal to 30 centimeter. Try to convert into meters, that is dividing by 100. We'll get either we can have it as 3 by 10 or 0.3. That's up to your convenience. So now we need to find the force between them. So we have the Coulomb's law. We can find force using the Coulomb's law. That is 1 by 4 pi epsilon naught Q1 Q2 by d square. So here 1 by 4 pi epsilon naught, substitute the value for that as 9 into 10 to the power 9. Q1 and Q2 as we have taken as 2 into 10 to the power minus 7 into 3 into 10 to the power minus 7. Denominator d square, either you can have it as 0.3 into 0.3 or 3 by 10 into 3 by 10. Since it is in denominator, we'll take the 10 to the numerator as 10 square. So 10 to the power minus 7 and 10 to the power 10 to the power minus 7. We have taken it as 10 to the power minus 14. As bases are same, we can add the powers. And already we have 10 to the power 9. So adding all the powers with base 10. So 9 plus 2, 11 minus 14 minus 3, and after cancelling all the terms we get 6. So final answer, the force between the two charges is 6 into 10 to the power minus 3 Newton. Since the given charges are positive, that is both the charges are positive, they repel each other. We know like charges repel and unlike charges attract. Here they repel each other. Question number 2. The electrostatic force on a small sphere of a charge 0.4 mu coulomb due to another small sphere of charge minus 0.8 mu coulomb in air is 0.2 Newton. What is the distance between the two spheres? What is the force on the second sphere due to the first? Like the previous question, we'll try to figure out the given question. So again here we assume the charges be Q1 and Q2. So here one is positive and one is negative. As they are opposite in charges, since they are opposite charges, they attract each other. So that is the main point here. The distance we are taking as R. We need to find the distance between the two spheres and they have given the force as 0.2 Newton. Force on Q1 due to Q2, that is 0.2 Newton. And since they have given the charges as mu coulomb, we try to convert to coulomb, that is multiplying into 10 to the power minus 6. So 0.4 into 10 to the power minus 6 coulomb minus 0.8 into 10 to the power minus 6 coulomb. So use the Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. As we need to find R square, take it to one side and take force to the right side. We know 1 by 4 pi epsilon naught value is 10, 9 into 10 to the power 9, and force is 0.2. Either you can have it as 0.2 or 2 by 10. Since it is in denominator, it will be reciprocal, that is 10 by 2. And Q and Q2, substitute the values as 0.4 into 10 to the power minus 6 into 0.8 into 10 to the power minus 6. So here we have the same base, same 10, power 9 minus 6 minus 6. So that is minus 12. So we get minus 3 and we have plus 10 in the numerator, that is power 1. So it will be minus 2. And denominator we have 0.4 and 0.8. I have written as 4 by 10 and 8 by 10. It will be 10 square. I have taken to the numerator as 10 power minus 2. On cancelling the other terms, the value will be 144. So 144 into 10 to the power minus 4. Since we need to find the distance, that is add, take the square root, it will be 12 into 10 to the power minus 2 meter. To convert to centimeter, multiply into 100, that is 10 square. So plus 2 minus 2 gets cancelled. We will get the answer as 12 centimeter. Now the second part, what is the force on the second sphere due to the first? Here, the force of attraction on the second sphere due to the first is a same, that is, again we'll be getting the force as zero point 0.2 Newton. So, the electrostatic force between two forces, it is interactive force, that is, force on Q1 due to Q2 or force on Q2 due to Q1 is same. So electrostatic force between two charges obeys the Newton's third law, that is action and reaction law. And I hope this will be clear. So if you have any doubt, please post it in the comment section. In next video, we shall proceed with the third question. Thank you.